Good morning everybody, myself Acharya Vishvendra, and today I'll discuss a worksheet on gas equations. So the question is, a gas follows a process P divided by V square is equal to constant, which I assume as K. So K here is the constant. The first question is, we have to draw the PV graph. So as we can see that P is equal to KV square, so P will be proportional to V square, so the graph here will be a parabola along the p-axis as shown in the figure. Next is, there are 2 points on the parabola, point A and point B. Corresponding to point A, volume is VA, pressure is PA. Corresponding to point B, volume is VB, pressure is PB. So we need to find the relation between them. So as it is evident from the equation that B upon V square is constant, so we can say that PA by PB will be our VA square by VB square, because P is proportional to V square over here. So P1 by P2 is V1 by V2 whole square. So from here we can say that PA upon PB is VA square by VB square. That will be the correct equation. Then we need to find the ratio of temperature. So temperature is proportional to PV for a constant amount of the gas. So we can say that TA by TB will be PA-VA by PB-VB. Now PA by PB is VA square by VB square into VA by VB. So from here we'll have VA cube divided by VB cube as the expression. Then we need to find work done from A to B. So we know that work done is integration of PdV from VA to VB. So P here is kV square, so it will be kV square dV integration. K is constant, so it will be taken out from the integration. And V square dV integration is V cube by 3 from the limit VA to VB. So from here we have work done as K by 3 VB cube minus VA cube. Next is, we need to find change in internal energy during A to B. So we know that change in internal energy is NCV delta T. So that will be NCV into TB minus TA. And TB minus TA can be deduced from this relation, so we can solve this question. Next question is heat given during the part A to B. So the heat change, I should say, is equal to delta U A to B plus delta W from A to B. So you can calculate delta Q from A to B using this equation. Then is molar specific heat of the gas during A to B. So it can be solved by using the equation delta Q is NC delta T. So from here C will be delta Q by N delta T. So using this equation we can find the molar specific heat. Next is PT relation. So from here we know that P is equal to KV square. So P is equal to K. V can be written as nRT by P whole square. So from here P is proportional to T square by P square. That gives PQ proportional to T square, or P proportional to T raised to power 2 by 3. Next is PT graph. So obviously T will increase, so P will increase, so the graph will look like this. Next is volume temperature relation. So we have P as KV square. P can be written as nRT by V. This is equal to V square. So we have the relation T proportional to V cube. So similarly we can see that on increasing V, T will increase, so the graph will be like this. Next we have VT relation, it will also be like this. Then we need to find VA upon VB into TA by TB. So TA by TB we have calculated that it is equal to VA cube by VB cube. It is cube over here. So that will give us expression as VA4 by VB4. Next we have a question that indicator diagram is given to you in the process 1, 2, 3, 4. We need to find T2. So using the equation P1 V1 by T1 is P2 V2 by T2, we can find T2. Then using the same equation we can find T3. And then using this equation we can find T4. Coordinates are given over here for different points. 4.1, pressure is P0, volume is V0. 4.2, volume is 3V0 and pressure is same over here, and at 3 volume is 4V0, pressure is P0 by 3. At 4 volume is 3V0 and pressure is P0 by 3. Then we need to find work done from 1 to 2. So as we can see, 1 to 2 is an isobaric process. So work done is equal to pressure into change in volume. Change in volume here will be 2V0. So work done will be 2P0 V0. Then is work done from 2 to 3. So 2 to 3 will be this process. So it's not a simple curve, so we have to take the area of the trapezium, that is over this figure, and area of the trapezium will be half sum of parallel sides into distance between them. Solving this, we will have 2 by 3 P0 V0. Then we have work done from 3 to 4. So as you can see, volume decreases, so work done will be negative, and hence work done will be minus of P0 by 3 into V0, that is minus P0 V0 by 3. Then in the next question, we need to find work done during 1 to 4. So we add all the works 1 to 2, 2 to 3, 3 to 4, and finally we will get work done as 7 by 3 P0 V0. Then we need to find change in internal energy during 1 to 2. So it is given by NCV delta T. So delta T will be, final temperature here is 3 T0, as it can be calculated, that final temperature will be 3 T0, initial is T0, so that will give 2 NCV into T0. Then is internal energy from 2 to 3, so that will be NCV delta T, and after solution we get minus 5 by 3 NCV into T0. Then we need to find internal energy from 3 to 4, that will be NCV delta T. Delta T here is T0 minus 4 by 3 T0, so from here we will get minus NCV T0 by 3. Then is change in internal energy during 1 to 4, so that will be NCV delta T. As 1 and 4 have the same temperature, as it can be calculated using the laws, so we can say that change in internal energy will be 0. Then is heat taken from 1 to 4, so that will be delta U from 1 to 4 plus delta W from 1 to 4, applying it on all the processes. So delta U from 1 to 4 is 0, and delta W from 1 by 4 is 7 by 3 P0 V0. So we have 7 by 3 P0 V0 as the work. So in this way it can be solved. If you have any doubt, you can ask in the comment section. Thank you and have a nice day.